Section 10.4. Now we want to simplify fractions. Simplify the fractions. Sorry, let me find the problem here. Radical 49 over 64. When you're dealing with a fraction first, we break the top and the bottom. There's 49 is 7 to the power of 2, 64 is 8 to the power of 2. Now, since the denominator is 2, 7 is released from the radical and 8 is released from the radical. But remember, since 7 is at the numerator and 8 is the denominator, they stay there. So when you remove a number, if that number is already at the denominator, it has to stay at the denominator. And if a number is a numerator, also stay at the numerator. 144 is 12 to the power of 2. So 2 and 2 is the same. So 12 is released, stay at the numerator. Y2 and 2 cancel. Y is released at denominator. I have x to the power of 10, and here is 3. 3 doesn't go to 10, but instead of x to the power of 10, you write x to the power of 9 times x to the power of 1. 64 is 4 to the power of 3. Then 21 remain, because you cannot even break it. X to the power of 9. 9 divided by 3 is 3. So x3 is released. Say 9 divided by 3 is 3. So x3 is released from the radical. x1, it doesn't, because 1 is less than 3. So 21x remain. 4 to the power of 3. 4 is released, but where does 4 go? Denominator. Y9. 9 divided by 3 is 3. Y is at denominator. Y3 is at denominator. Five doesn't go to 4. So instead of p to the power of 5, you write p4 times p1. 8 is fine. 12, fine. So they all are divisible by 4. So we start. P4, and this is 4. P is released. Q is 8. 8 divided by 4 is 2. So Q2 is released. This P stay. Denominator 12 divided by 4 is 3. So R3 is released. But remember, it has to stay at the denominator. So you could either do it like that, or you could just continue this fraction line. Next subject is, we call it combination of two radical. So, but in formal divisions, remember before we had radical nx multiplied by radical ny, you combine into 1 and you multiply. Here, you combine these two into one radical in this formula, but then it would be a fractions under. See the difference of these two? This is multiplication of two radical with the same root. This is division of two radical with the same root and the different bases. So in that case, I have cubic root and cubic root. I just combine into 1, and under that, divide these two. And then 15 goes to 30 is 2. Both radical has power of 2. Combine into 1, and under that, this is numerator, this is down to 8 goes to 88, 11, x, y3. Since the power is 2, and I have y3, I write y3 as y to power of 2 times y to power of 1. This one is released from the radical. That would be here. But 11y remain. This 3 is outside of the radical. So 1 over 3 You keep that outside of the radical. These two both have the same root. The root is 2. You combine into 1 fractions. 3 goes to 324 is 108. And 108, I show you here how to break the 108. You always divide by 2 and then 3 and then 5. So here 2, 3. So 108 is 3 times 3 to power of 2 because you have there are 3 here. And 2 to power of 2. See? So these two, they both are released from the radical. But 3xy remain. Xy both have power of 1, they stay. 3 also stay, but these two removed. And there is already a 3. There is already this 3 here. Cancel. So that's the answer. The same thing. We combine these two into 1 fractions. Under the fraction, you have this. Remember, anytime you have a negative exponent, you got to bring it up with a positive exponent. So this y to power of negative 2, it was at the denominator, now it comes to the numerator here. Has y to power of 2. So you have y to power of 2, y to power of 25, that gives you y to power of 27. Okay. Now, 81 is 3 to power of 4. 12 goes to 4. This is fine. 27, 4 does not go to 27. So instead of 27, I write y to power of 24 times y to power of 3. These 3, they all are divisible by 4. 4 and 4 cancel, 3 is released. 12 divided by 4 is 3, so x3 is released. 24 divided by 4 is 6, so y to power of 6, y to power of I think it should be 24 divided, something is not right, we gotta fix that one. So 3 remain. This should be 6. Okay, and then y3 remain. Y3 remain there. All right. Now, what is this? Next subject is rationalizing. Rationalizing denominator. What does that mean, rationalizing denominator? You know, when you have a fractions like, let's say 2 over radical 5, there is a root, there is a radical at denominator. When we ask you to rationalize the denominator, rationalizing the denominator, rationalize denominator means we don't want to have any radical at the denominator. So in that case, we multiply this by radical 5 over radical 5 because we know radical 5 over radical 5 is 1. But then radical 5 times radical 5 is 5. And I have 2 radical 5. So what I did, I changed 2 over radical 5 to this. This is a new fractions is equal to that. There is no change if you calculate these two are the same numbers. The only difference is I don't have radical at the 5 anymore, at the denominator anymore. Rationalize the denominator. Okay. Why radical 5 times radical 5 is 5? Because radical 5 times radical 5 is combined radical 5 times 5, or radical 5 to power of 2. Remember, 2 and 2 cancel is 5. So if you take a radical and multiply by itself, doing that, radical is removed. They call this rationalizing the denominator, because you are moving. Let's say I have something like that, radical 3 over 7. And I ask you to rationalize the numerator. That means I don't want to see radical at the numerator. It doesn't matter whether it's a denominator or not. I just don't want to see it here. So you multiply by radical 3 over radical 3. Then these two, when you multiply, is 3, and at the bottom is 7 radical 3. See, what I did, I rationalized the numerator. Means I removed the radical from numerator. They call rationalizing the denominator. And that's what we did in all these problems here. You want to rationalize radical 3, you multiply that. So you end up having this. I want to rationalize the denominator. This is a tricky one because if you take cubic root of 2, let's say I want to rationalize this problem. Let's look at this example. Cubic root of, let's say like 5. If you multiply this by cubic root of 5 times cubic root of 5, then what do you have here? You have cubic root of 5 times 5 is 25, or 5 power 2. You cannot reduce the 5 because the root is 2, is not 3. Okay? So when the root is 3, you have to multiply both sides by 25 here, or 5 to power of 2. See? Because in that case, when you combine these two, then you have 5 times 5 to power of 2 is 5 to power of 3. Then you could release the 5. So it depends what root you have. So here, cubic root of 2c, I have to multiply by cubic root of 2c to power of 2. So when you combine these two, would make it 2c to power of 3. And then you have cubic root. See? Then you could cancel this 3 and 3 and remove that. That's why we put 2c to power of 2. Rationalizing denominator, this is just radical 63's root is 2, so you just multiply by radical 63. And then we did some 63 is 7 times 9. And 9 is 3 to power of 2. 3 is release. 63 is already out. And then this is a larger number. You have to take 1225 and break it into these. 500 is 100 times 5. Simplify all this. Even cancel some of these A and A. 6 is A5. And then some of these A comes out. And you come up with final. This is kind of a lot of numbers and variables involved for these problems. Now, rationalize the numerator. You want to rationalize this, right? So in that case, you take cubic root of 2 times cubic root of 2 to power of 2. So in that case, what you have on the numerator, you have just 2. See, you have to multiply by 2 to power of 2 or multiply by 4. So when you combine, is 2 times 4 is 8 or 2 to power of 3. See here on this one? I'll break it into this first. I want to rationalize this one, right? Since this is 3 and this is 5 to power of 1, I need 5 to power of 2. That when I combine these two, you give me 5 to power of 3. This is A4. So if I multiply that by A2, that give me A6, and 6 is divisible by 3, see? So it would be 6 divided by 3 is A2. So at the numerator, I no longer have radical. And this is rationalizing the numerator.